Yeah, our model specification can be described using this equation where IIT is the spreads between the 10-year government bond interest rate of country I and relative German bond. Uh, this means that we are considered panel data because we have two dimension of variabilities which are in time and in space between countries. Xit is the vector containing the explanatory variables. Epsilon it is the standard the error term. We use as explanatory variables as global risk aversion. We have used the VUIX index or so the volatility index of the US stock market and the difference between the AAA US bond, US corporate bond, and the treasury bill, which is a measure of risk aversion. As solvency risk, we have used both debt or deficit GDP ratio, but also de facto fiscal space, which is a measure of um, a ratio between the debt, the government debt, and the total tax revenue, the average over the last 5 years um in our paper. Liquidity risk, we have used the ratio between the government debt of country I at time t and the um, euro area wide total, using the total euro area at 27 countries debt in order to assess the liquidity of the debt. Final, in order to assess the impact of the euro breakup, as first stage we use our indicator of euro sustainability, the difference between our shadow exchange rate in count for country I and the shadow exchange rate for Germany. So we have an assessment of the shadow devaluation for country I. Also, liquidity risk and solving risk are considered in difference in respect to the benchmark country Germany. So after assessing, after in the second stage, after assessing the relevance of the euro breakup risk, we have analyzed the phenomenon of contagion from Greece to other peripheral European countries. Okay, in order to compute the shadow devaluation rate in equation 4.1 respect to the fixed parity, we use the same estimation of our first paper, the sustainability of monetary union, can the euro survive? So we use the Audrey-Prescott filter for the output gap. We use the long-run relationship between the trade balance and the real effective exchange rate, the nominal fixed parities. As first test, in order to identify the long-run relationship between the main variables in our empirical investigation, so the spreads, interest rate spreads, and the other explanatory variable, we start with the panel least square estimation, which are reported in table 5 and 6. Table 5 shows the main results of panel least square estimations over the whole period 2000-2012, and the pre-crisis period between 2000 and 2007, post-crisis period between 2008-2011. R square is the adjusted R square. The main variables S are the RT, which is the difference between the shadow exchange rate of country I, the shadow exchange rate, and the relative uh, shadow exchange rate for Germany. This is the difference between the debt GDP ratio and the debt of GDP ratio in Germany. This is the difference between the liquidity of, and the liquidity of Germany, so it means the ratio between the government debt and the total Union 27 government debts. And CPS is the difference between the AAA corporate bond spread, corporate bond interest rate, and the treasury bill interest rate. What we can see from this table, F is the redundant fixed effects test. Here we report the p-value, so we can reject that fixed effect are redundant, as we can see from these three tests. What we can see is also that all coefficients are significant, so all these fundamentals are significant in our estimation, but because the Darby-Watson statistics is very low, we cannot dismiss the hypothesis that these regressions are spurious. These are spurious regressions. Now, if we consider this panelist estimate, which we have the spreads at time t, but also the spreads with lag 1, so the previous period, ist minus 1. What we can see from this this table is that we in this case the Darby-Watson statistics becomes higher respect to the first one, so our hypothesis of spurious regression is confirmed also from this table. We see that the fixed effect redundant are accepted, this hypothesis, and we can see that the coefficients are of the interest spreads in the previous period are close to 1. So we start with the unit root test, panel unit root test in the whole sample periods, and what we can see from this test is that at level we cannot reject the hypothesis that the series have unit root, but we can dismiss this hypothesis in first difference. So this means that variables are integrated over the 1. This is the panel co-integration test. Use the Johansen-Fischer test and the Kao test. The Johansen-Fischer test reject the hypothesis of no co-integration and at most 1 co-integration, at most 2, and accept at most 3 and at most 4. Kao test reject the hypothesis that we have no co-integration. So after checking that if you use panelist square, we have spurious regression, and that series have a high degree of persistence due to the fact that they are integrated on the same order, so integrated of order 1, we can estimate the longer run relationship between the spreads and the other variables.